So this question here is asking us what values of x and y maximize p for the objective function p equals 3x plus 2y within the feasible region defined by the given system of constraints. And so it's multiple choice, right? So you've got A, B, C, and D to pick from. And ultimately the question is asking for, what x and y are going to maximize that profit function. So, you could plug in the x and y points and see what you're going to get. So if you plugged in like the first point right there, you did 3 times x plus 2 times y, then you're going to get a p-value of 6 with that. And then 3 times 2 plus 2 times 6, that's going to be 18 for p. For option C, you're going to get 12 plus 6. You're going to get the profit is 18 there. And then finally, 3 times 4 plus 2 times 4 is going to give you profit equal to 20. And so it's asking what's going to maximize, and so it seems like, oh, hey, option D is going to maximize, which is true of the options given, but the fact also is given that we need to have it be within the feasible region that's defined within a system of constraints. And so it turns out that if we were to take this point D and consider it within a system of constraints, it's not going to satisfy everything in that system of constraints. Because, for example, you'll see if I put in the x and the y coordinates of 4 and 4 in that constraint, then you actually get 8 is less than or equal to 7, which is not true. So it's not actually going to be in the feasible region there. So it turns out that D is not going to be able to work, right? So now it kind of be between B and C, and you really have to consider that in terms of the systems of constraints. So we might want to kind of sketch this out and see what we have. So there's a couple easier constraints with those right there. So with the x is greater than or equal to 0, that means that we kind of have this vertical line, the y-axis there, and then with the y is greater than or equal to 0, we're going to have that. So we'll have only non-negative values of x and y. With the 3x minus 2y is less than or equal to 6, if we solve that for y, so negative 2y is going to be less than or equal to negative 3x plus 6, and then we have to flip the sign because we divide by a negative, so we're going to get positive 3/x minus 3 then. So negative 3 up 3 over 2, up 3 over 2, up 3 over 2. So that there is going to be another one of our constraints that we're going to have to be above. And then we've got one other constraint with the x plus y is less than or equal to 7. Really is just that line right there, which has a negative 1 slope and a positive y-intercept there at 7. So if we shade in this feasible region right here, we're going to actually have to be above the orange line, but we'll still be below the yellow line. But then, yeah, so we're going to have to be in this particular quadrilateral sort of region that you're seeing right here. And so kind of based on what we're seeing among the remaining options here is, so like for example, the 0.26 is going to be right there, and then we also see the 0.43 is going to be right there of option B and of option C there. And clearly option B is outside of the feasible region, and so it's not going to be able to satisfy the system constraint, so we can kind of rule that out. But you'll notice that 4,3 is within the feasible region, and of course it's also at a corner point, and we know that corner points are going to be able to also maximize. And so it turns out that the correct answer for that then should actually be option C, to maximize that profit function P, but then also still be within the feasible region.